In this video, I will introduce you to basic derivatives rules, such as a power rule, a constant rule, a constant multiple rule, as well as addition and subtraction rules for derivatives. So, derivatives rules is just a shortcut for finding derivatives instead of using a long process involving limits. So, let's get started. Now, the first one is a power rule, and all it says, if you have a power of x, let's say x to the nth, all you want to do is just bring this power in front of your term and reduce your power by 1, so knock your power by 1, so your new power becomes n minus 1. Second one is a constant rule, which says that the derivative of any constant, any number, is just 0. The next one is a constant multiple rule, and it says that if you have a constant, let's call it c, in front of your power term, you want to keep the constant and apply the power rule to the rest. So, meaning you want to bring your power n in front, and again decrease your power by 1. So actually c and n is going to be multiplied together. It's worth to remember that the derivative of x is just 1. Actually, this rule derives from the power rule, but again it's worth to remember as a separate rule, since it comes out a lot when you do calculus. Again, you could think of this as x being x to first power, so it's implied, it's understood, the power being 1. Another rule worth to remember is just if you are given the constant in front of the x, let's say cx. So the derivative of x is going to be just c, since we want to apply the multiple constant rule that keeps your constant. And the derivative of x is just 1, so x goes away. Now, let's have a look at example. Say we need to find the derivative of x cubed, so x cubed prime. By a power rule, all you want to do is just bring this power 3 in front of your term and reduce your power by 1, so knock it down by 1. So your new power becomes 3 minus 1. Make sure you simplify your expression as much as you can. So you want to keep this 3 and 3 minus 1, that would leave you with 2. So the derivative is going to be 3x squared. Alright, another example. Say we have 3x to the 4th and we need to find the derivative. So first of all, we have a constant 3 in front of your term, so you want to keep it by a constant multiple rule. And we're going to apply a power rule to the rest, so bring this 4 in front and reduce your power by 1. So 3 times 4, that would leave you with 12, x, and 4 minus 1, you are gonna left with third. So 12x cubed, that's your derivative. Next example, say we have negative 5 and the derivative of any constant, any number, is just 0. Alright, let's move on. As a quick summary, so here's the table of all derivatives rules that you need to remember. Alright, some problems to carry out. Find the first derivative of the following functions. More problems. Alright, find the value of the derivative of each of the following functions at the given value of x. Say we have y equals x cubed and x is 1. So first of all, you need to find derivative y prime, which is 3x squared by a power rule. The next step, all you want to do is just take this x equals 1 and you want to replace your x with 1. So in other words, you want to substitute 1 into your derivative. So y prime of 1 equals 3 times 1 squared, which simplifies to just 3. So that's the answer. So the same way you would do the other functions. Now, determine the first derivative of the following functions. More examples. let's have a look at letter B, 1 over 12x. So all you want to do, first of all, we want to just separate this fraction in front of your x term. So it's 1 over 12 times 1 over x. Since x appears in the bottom of your fraction, you want to bring it up by making your power negative. So x actually has this implied understood power of 1. So when we bring it up, your power becomes negative 1. Now we are going to apply a constant multiple rule. We want to first of all keep 1 over 12 and use a power rule. So we want to bring negative 1 in front and reduce your power by 1. So minus 1, which becomes negative 2. And we won't get back, so we want to bring your x term down in the denominator by making your power positive. And this negative sign we can pull out in front of the fraction. Now let's jump into addition or subtraction rule for derivatives. If you are given multiple functions, 2 or more, let's say f and g, so in order to find the derivative of their sum or difference, all you want to do is just take the derivative of each chunk of each function one by one and string them together for the full derivative. Now let's have a look at example. Say we have y equals 3x plus x squared and we need to differentiate this function. So all you want to do is just take the derivative of the first one, which is 3x, and take the derivative of the second function, which is x squared. So again, we want to just differentiate it one piece at a time. So the derivative of 3x, it's going to be 3. So the derivative of x, remember, is just 1x goes away. And the derivative of x squared is just by the power rule 2x to the power 2 minus 1. And it becomes 3 plus 2x. That would leave you with 2x plus 3. Some problems? Alright, let's have a look how to find the derivative if you are given two factors being multiplied, two functions being multiplied together. First of all, you want to distribute, you want to FOIL everything out, and it becomes for the letter A, x squared plus x, and the derivative of this is gonna be just 2x plus 1 by a power rule. So if you are given a fraction and your top is kind of heavier, so you want to split your fraction. So you want to split the numerator by dividing. So 3x divided by x plus 2 divided by x. So you want to break up this fraction and after proceed with derivatives. Review. Some miscellaneous problems. Perfect.